Welcome to our electrical engineering YouTube channel. In this video, we will see an example on Thevenin's theorem. To get these notes, you can visit our website link electrical-engineering.app. This website or app is especially designed for electrical engineering students. You can get notes, MCQs and much more. The link of this website is in the video description. Question: develop Thevenin's equivalent circuit between the points A and B. Here we have to develop a Thevenin equivalent circuit A and B in figure and find current in RL is equal to 10 ohm. And also we have to find the current through this 10 ohm resistor by using Thevenin's theorem. Solution: first of all, we will take this circuit. Now step number 1 is to find the value of RTH. So to find RTH, remove RL and turn off all independent sources. Now here, when we remove this RL, so this will be our RTH. But here we also have to turn off all independent sources. So as we can see, this is a voltage source. Now when we turn off a voltage source, that time it will be replaced by short circuit. So here this will be short circuit. Now we can easily find the value of RTH. So RTH is equal to this 7 ohm, then plus this 15 ohm is in parallel with 7 ohm. So it will be 15 into 7 divided by 15 plus 7. So 15 into 7 divided by 15 plus 7. So this will be our RTH. So let's calculate this in calculator. It will be 7 plus 15 into 7 divided by 15 plus 7. So it is equal to 259 divided by 22. Now we will keep this value as it is to get the precise answer. So RTH is equal to 259 divided by 22 ohm. This is the value of RTH. Now step number 2 is to find the value of VTH. So here we can write step number 2 to find VTH. Again we have to remove RL and find VOC. Now this VOC is the open circuit voltage. So let's remove this RL and now this will be our VOC, or directly we can write VTH. So here this will be positive and this will be negative. Now here we can see this 7 ohm is open circuited. So that's why this will be our VTH. The voltage across this 7 ohm will be our VTH. So here we can write this will be our VTH. Now let's assume the current through this loop is current I. Now according to the direction of this current, this will be positive, this will be negative, this will be positive and this will be negative. So let's apply KVL to loop. Now here according to KVL stands for Kirchhoff's voltage law. Let's say we are starting from this point, so it will be minus 10, then plus 15 into I, then plus 7 into I, is equal to 0. Now here we can easily find the value of this I. So it will be minus 10 and this will be 15 plus 7. So it will be plus 22I is equal to 0. If we take this on this side, so it will be 22I is equal to 10. So therefore I is equal to 10 divided by 22 ampere. Now we have to find the voltage across this 7 ohm. So it will be simply 7 multiplied with current I. So here we can write VTH is equal to 7 into I. So it will be 7 multiplied with the value of I is 10 divided by 22. If we solve this in calculator, it will be 7 multiplied with 10 divided by 22. That is equal to 3.18, or we will keep this value as it is, 35 divided by 11 volts, or we can write this value also 3.181 volt. Now this from this we will get the more precise value. Now let's draw Thevenin equivalent circuit. So for Thevenin equivalent circuit we need VTH. So this is our VTH. Now this is our RTH. And this is our VTH. This is positive terminal, this is negative terminal, and this is our load resistor RL. This is load resistor RL. The value of VTH is 3.181 volt. The value of RTH is, now here we can write the value in fraction, or we can write this value as 259 divided by 22. So it is 11.77. So let's write 11.77 ohm. So it will be 11.77 ohm. And the value of RL, here we can see the value of RL is 10 ohm. So it will be 10 ohm. Now we can easily find the value of current IL. So the direction of current IL will be like this, because positive terminal here. So the current flows from positive terminal to negative terminal. So IL will be like this. Now IL is equal to voltage divided by resistance. So here voltage is VTH divided by RTH plus RL. Here the value of VTH is 3.181 divided by RTH value is 11.77 plus RL value is 10. If we solve this in calculator, it will be 3.181 divided by 11.77 plus 10. So it is equal to 0.146. 0.146 ampere is the value of current IL. 0.146 ampere. Now here, this circuit is known as Thevenin's equivalent circuit. So here we can write figure. Thevenin's equivalent circuit. Now what we have to find in this question, we have to find Thevenin's equivalent circuit and current. Find the current in RL. That is, we have to find IL and Thevenin equivalent circuit. So here, this is our Thevenin equivalent circuit, and this is the value of current IL, that is load current. So this is how we can solve problem by using Thevenin's theorem. Don't forget to visit this website link, electrical-engineering.app. And don't forget to like, share and subscribe to this channel, and thanks for watching.